let my dot cam warm up here. There we go. So we are still looking at SOHCAHTOA, so I am going to write that out at the top of my paper. Okay, so we still want to remember that, so we know which trig ratio to use. Now today we're going to go over angles of elevation and depression. Okay, so we're looking at different angles. So to make a field goal, a kicker must kick the football with enough force and at an appropriate angle of elevation to ensure that the ball will go through the goal post. This angle changes depending on the placement of the football from the goal post. Okay, so you have to see what angle to kick it at to go through that goal post. So as a reminder, what a horizontal line and a vertical line are. Horizontal is left and right. Vertical is up and down. So if I say the horizontal distance, you're looking for that flat line that's horizontal. If I say vertical distance, that is the distance up and down. Okay, so our different angles, we have an angle of elevation. That is the angle formed by a horizontal line and an observer's line of sight to an object above the horizontal line. So when you're looking up at something, you will create an angle of elevation. So if I have this person here, right, from their line of sight, you always have a horizontal line. Okay, from their line of sight, you always have a horizontal line. So here would be my horizontal line. Okay, now if this person is looking up at something, okay, doesn't matter what they're looking at, if they're looking up at something, that angle created between that horizontal line and their line of sight, right here, that is your angle of elevation. Okay, so that's the angle of elevation created. So then the angle of depression is just the opposite. So that is the angle formed by, again, the horizontal line and an observer's line of sight, but this time to an object below the horizontal line. So you're looking down at something. Okay, looking down at something to create that angle of depression. So if I have a person up higher, okay, that person still has that horizontal line, okay, from their normal line of sight. Okay, so we still have a horizontal line. Now, if that person is looking at something below that line, okay, that angle created by that line of sight is called your angle of depression. And that would be this angle right here. Okay? Shh. We are quiet, please. So those are our two angles that we're looking at today. Okay, now horizontal lines are all parallel to each other. Meaning the angle of elevation will be the same or equal to the angle of depression. Okay, so they are equal to each other, and I'll show you that in the picture on the left. So here you have your two people. I know this is hard to see. There's a person standing here and a person standing up here further. Now this dashed line is the horizontal line coming off their line of sight. Okay, so the person up here, this is their horizontal line. Person down here, here's their horizontal line. Because you're going down to look at something. Down to look.
So what, angles are always depressed?
No. Depression doesn't mean just the feeling. There's multiple meanings to depression. So here, if my person down at the bottom here is looking up at this person here, right? Shh, quiet. if this person down here is looking up at the person at the top, off of their horizontal line would be this angle of elevation created. Okay, so that's the angle of elevation to that person. This person up here is looking down at this person, so they have this angle of depression. Now, since those two horizontal lines are parallel, okay, these two angles would be considered alternate interior angles. That is why they are congruent to each other. Okay, so your angle of elevation is equal to your angle of depression. They are the same. So we are going to do a couple problems here. We do need to be able to draw out and make a sketch of what's going on in each of these problems. Okay, so you should create a right triangle in each problem. So example 1. Okay, Leah wants to see a castle in an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees. She knows that the castle is 190 feet tall. If Leah is 5.5 feet tall, how far is she from the castle to the nearest foot? So, our information that we need the angle of elevation is 38 degrees. She knows that the castle is 190 feet tall. We know Leah herself is 5.5 feet tall. Okay, and we want to figure out how far she is from the castle. Now we want to make a sketch of what's going on. So here I would have a castle. Okay, you can draw your castle however you want. Okay, mine's not even going to look like a castle. It's going to look like this. It's a tower, whatever. Okay, tower, castle, same thing. Okay, what do we know about this castle? It's 190 feet tall, so I want to label that. So from the bottom to the top is 190 feet. Okay, I also know I have this person, her name is Leah, standing further away from that castle. How tall is Leah?
5.
Okay, so we know she is 5.5 feet. Now, we just talked about what an angle of elevation was. So we need a horizontal line coming off of Leah's line of sight, right? Okay, so I have this horizontal line. Now she's looking up at the top of the castle. Okay, so we're looking up at the top of the castle there. Now the angle that was created between her horizontal and her line of sight is that angle of elevation. That is 38 degrees. Now, I have this triangle formed. Do you kind of see that? That triangle formed? Okay, it is a right triangle. However, look at where Leah's horizontal lies. Does it lie at the very bottom? No. Okay, I need to figure out what this length is right here, from the top to her horizontal line of sight. How do I do that?
Minus 190 minus 5.5.
Yes. Okay, so to find this length here, I would do 190 minus 5.5. That's 184.5. So this is a lot going on. So once you get this picture and you know each of the measures, okay, I want you to redraw your triangle just as a triangle, okay? So I'm going to redraw, sketch a right triangle. Okay, so here's my triangle. I know this length right here, I found to be 184.5. Okay, I know this angle is 38 degrees. Now I want to go back to my word problem. What am I trying to find? Okay, what am I trying to find? Well, I'm trying to find how far she is from the castle. Okay, how far away she is from that castle. So which one of my lengths would that be? It would be the bottom one. Okay, so I'm trying to find how far away she is from that door. So now that I've set up this right triangle, all I have to do is use my trig ratios like we were before. Okay, so I'm going to go from the angle I was given. Okay, so I have to go across to get to this side. So that is the opposite side. This x value here is the side next to that angle. So that's the adjacent. So I have O and A. So I'm going to use tangent. Okay, so tangent of this angle, 38, is equal to, opposite side is 184.5 over the adjacent side is x. All right, what's my next step to solve this? Multiply by whatever's in your denominator. In this case, it's x. Okay, I want to cancel out that denominator. So I have x times the tangent of 38 is equal to 184.5. What's next?
Divide by 200.
Good. Okay, so then in your calculator, we can take 184.5 divided by tangent of 38. Okay, to get an answer of 236.15. Now, if it asked me to round it to the nearest foot, what would that be?
Point would just be 236.
It would just be 236. So she is 236 feet away. Yep. Write out a statement. When you're given a word problem like this, I usually write out just a statement of what my answer is. So, yeah, I'd like you to. Okay, questions on this problem? Questions on this problem? All right, let's do another one. Okay, so example 2. At the circus, a person in the audience at ground level watches the high wire routine. A 5'6" tall acrobat is standing on a platform that is 25 feet off the ground, not round, off the ground. How far is the audience member from the base of the platform if the angle of elevation from the audience member's line of sight to the top of the acrobat's head is 27 degrees? So again, I'm going to pick out the information I need. Okay, so I have a 5'6" tall acrobat. Okay, we have that person standing on a platform that is 25 feet off the ground. Okay, we have an angle of elevation of 27 degrees. Okay, and we want to find how far the audience member is from the base of that platform. Okay, so making a sketch. I have this platform. Doesn't matter how you draw it. Okay, this is my platform with our acrobat standing on it. Okay, acrobat standing on a platform. We have an audience member down here watching, right? Now I know the platform is 25 feet off the ground. Okay, so this length from the top to the bottom is 25 feet. Okay, I also know that the Acrobat is 5 feet 6 inches tall. That is not 5.6. What is it? 5.5. Okay, 6 inches out of 12 is half. So it is 5.5 feet tall. Okay, so our Acrobat here is 5.5 feet. Now our audience member's horizontal line of sight is at the floor. Okay, it's at the base. Okay, so our horizontal line should hit our audience member. Now their line of sight is going to the top of the Acrobat's head. Okay, so we should have a line of sight from the top of that Acrobat's head. Now that angle created is your angle of elevation. Okay, that angle of elevation was 27 degrees. Okay, and I'm trying to find how far away the audience member is from the base of that platform. So I'm looking for this distance on the bottom here. So that's going to be X. Shh. Guys, quiet please. So now that I have my sketch, I want to locate the right triangle within that sketch. And I'm just going to redraw it to make it easier to look at. So here's my right triangle. Okay, I know this angle here is 27 degrees. I'm trying to find that horizontal distance. That's my X. Now this vertical distance isn't 25. What is it?
Oh, it's 30.5.
It is 30.5. You have to add those together this time. Okay, so you want that total length. So you'd add both pieces together. So here I have my triangle. Now again, I can use SOHCAHTOA to figure out that final side. So I'm going to go from the acute angle I'm given. That's 27 degrees. My side of 30.5 is across from that angle. So it is opposite. That X value is next to that angle. So adjacent. So I have O and A. So that will be tangent. So we're taking tangent of this angle is equal to the opposite side over the adjacent side. So multiply by your denominator, which is X. So I have X times the tangent of 27 is equal to 30.5. I still need X by itself. So divide both sides by a tangent of 27. So that I end up with X is equal to 30.5 over tangent of 27. And again, you can enter that into your calculator. And I got 59.06. Okay, now if I look back at what I was actually trying to find, we're trying to find how far the audience member is from the base of the platform. So I would write out the audience member is 59.06, and we're working in feet. Away. Okay, questions on example 2? Okay, questions on example 2? No, we're okay so far? All right, then example 3 is an angle of depression example. So the last 2 were angles of elevation, so this one is a little bit different. So a search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. If the angle of depression to this other person is 42 degrees and the helicopter is 18 feet above the water, what is the horizontal distance from the rescuers to this person? Okay, so we need a helicopter.
Submarine.
Is that better? Now does it look like a helicopter?
Now bring it. Now put a little ladder on it.
No, I'm okay. All right, so it's over the water. Okay, there's a person still in the water. So here's the start of my picture. Now, I want to pick out this information. So I know that the angle of depression to this other person is 42 degrees. I also know the helicopter is 18 feet above the water. Okay, so helicopter, 18 feet above the water. Now, since the helicopter is the one looking at the person, the helicopter is where you need to draw in that horizontal. Okay, so I'm going to go from here. We have our horizontal. The helicopter is looking down at our person. So this is where it gets tricky. You have to decide which of these angles is your angle of depression. Is it this one or is it this one? Okay, your angle of depression is always between your horizontal line and the line of sight. So that is this angle right here. Okay, so that angle of depression is 42 degrees. Okay, angle of depression always between horizontal and your line of sight. So now what we're looking for, is the horizontal distance, okay, from the rescuers to that person. Okay, so that would be this length at the bottom right here. So we're looking for that horizontal distance. Shh, you guys, I need you to stop talking. So now my picture looks kind of funky, right? Okay, so I have an angle up here, but I can see this right triangle right here, right? Well, at the beginning, I said your angle of elevation is equal to your angle of depression. So if this person were to be looking up at the helicopter, right, that would have an angle of elevation right here. Well, your angle of elevation and angle of depression are equal, so this angle must also be 42 degrees. Okay, they are alternate interior angles. They are equal to each other. So now that I have my triangle formed with that angle, I can redraw it to make it look a little bit nicer.
Oh my God.
Okay, so here is my triangle. Shh, you guys, I need you to stop. Here's my angle. This side is 18, this side is x, and again we can use our trig ratios to solve for that side. So I want to go from my angle 42 I have a side of 18. That is opposite. Side of x is adjacent. Again, I'm going to use tangent. No, it is not always tangent for these problems. It just happened to be on our examples. Okay, not always tangent. So I'm using tangent of 42 is equal to 18 over x, multiply by x, and divide by tangent of 42. And that's what I can plug into my calculator. Okay, so I got x to be 19.99, so I can say that's about 20. Okay, so that person is about 20 feet away.
Well, also, how fast is that helicopter going?
Helicopter is staying in one spot. Hovering. It's hovering in one spot.